Good morning, student. Today we are going to learn about delta modulation. After the completion of today's session, you are able to define delta modulation, explain the process of delta modulation and demodulation. So, what is delta modulation? The type of modulation where the sampling rate is much higher and in which the step size after quantization is of a smaller value, such a modulation is termed as delta modulation. Delta modulation is a simplified form of DPCM technique that we already discussed in our previous class, and it is also called as 1-bit DPCM scheme. As the sampling interval is reduced, the signal correlation will be higher, and this technique overcomes the disadvantages of pulse code modulation. So in pulse code modulation, signaling rate and transmission channel bandwidth are quite large. So in delta modulation, the modulator transmits only 1 bit per sample. Here the present sample value is compared with the previous sample value. So here it compares the present sample with the previous sample, and the input signal is approximated to the step signal by the delta modulator. The difference between the input and this approximated signal, that approximated signal is a staircase signal, means like this. Okay, this one is the staircase signal. So the difference between the input signal and staircase approximated signal is given as plus delta or minus delta. If the difference is positive, then approximated signal is increased by one step, means we can say plus delta. If the difference is negative, then approximated signal is reduced by delta. So here, this is the block diagram. Always remember, in the starting of the block diagram, a sampler is always present. Why sampler is required? Sampler converts the continuous signal into a sampled signal. So here is the sampled input given here, that is x of NTS, and this one is the previous sample, and this section compare these two inputs. So it find out the difference between them. So at the output we get a different signal which is denoted as error signal, denoted as E of NTS. So when E of NTS is positive, then E of NTS is positive, then B of NTS is plus delta. Okay. When E of NTS is negative, then B of NTS is minus delta. Okay, that means we can say when the sampled input signal is less than previous sampled signal, then the B of NTS is minus delta. When the X of NTS is greater than equal to X cap NTS, then B of NTS is plus delta. Okay, then when the B of NTS is plus delta, then binary 1 is transmitted. When B of NTS is minus delta, then binary 0 is transmitted. Okay, so let's discuss about this lower part. So this one is the accumulator. In accumulator there is a summer is present. The summer in the accumulator adds quantizer output with the previous sample approximation. So it adds the B of nTS and U of n-1 TS. So always remember this X cap nTS and U of n-1 TS are both are same signal. So the summer add these two signals. This gives present sample approximation. So at the output we get the present sample. Okay, then the previous sample approximation U of n-1 TS is distorted by delaying one sample period. If this one is the present sample, then we just delayed it for one sample period. Then here we can get U of n-1 TS delayed by one sample period, so -1. If we have 2, then if we want to delay by 1 bit, then 2 minus 1 equal to 1, like this. Here we delayed it by one sample period, then at the output we get the previous sample. Like this the process is continuous. Okay, next is the delta demodulation. This one is the block diagram. So at the receiver end, the accumulator and low pass filter are used. The accumulator generates the staircase approximated signal output and is delayed by one sample period. So this one is the accumulator. It generates the staircase approximated signal, and this delay helps to delay the signal by one sample period. It is then added to the input. That delayed signal is added to the input signal using this section. If input is binary 1, then then it adds plus delta step to the previous output. Okay, if input is binary 0, then one step delta is subtracted from the delayed signal. Then the low pass filter. The low pass filter has the cutoff frequency equal to the highest frequency in the modulating signal. This low pass filter smoothens the staircase signal to reconstruct original message signal, that is x of t. Next is the advantages and disadvantages. First is the advantages. It transmits only one bit for one sample. So since the delta modulation transmits only one bit for one sample, therefore the signaling rate and transmission channel bandwidth is quite small for delta modulation compared to pulse code modulation. The transmitter and receiver implementation is very much simpler for delta modulation. Next is the disadvantage, that is slow overload distortion and granular noise. So here see this diagram. When the rate of rise of input signal x of t is so high, here we can see the signal is increasing too fast. The step size delta becomes too small for case signal to follow the step segment of x of t. So here we know that the step size is always constant. So it looks like step size delta is too small for this staircase signal to follow this input signal. Here there is a large error between the staircase approximated signal and the original input signal. Here there is a large difference is present as it cannot approximate it properly. So this error is known as slope overload distortion. To reduce this error, the step size must be increased when slope of signal is high. Next is the granular noise. Granular noise occurs when the step size is too large compared to small variations in the input signal. This means that for very small variations in the input signal, the staircase signal is changed by a large amount because of large step size. So here we can see the signal is changing slowly. Okay, but the staircase signal is going as per its step size. So here also it cannot properly approximate the input signal. So a large difference is present here. So this type of error is known as granular noise. So we can say when the input signal is changing too fast, at that time the fixed step signal cannot properly approximate that input signal. So there slope overload distortion is occur, and when the signal is changing slowly, input signal, the fixed step signal also cannot approximate properly. At that time granular noise is occur. Means in this case the step size looks like large enough to approximate it, but in the previous case it looks like very small to properly approximate it. So this is the disadvantage, and this type of problem can be solved by making variation in step sizes so that it can properly approximate the input signal. Comparison between pulse code modulation, delta modulation, adaptive delta modulation and differential pulse code modulation. So this one is new one, that is adaptive delta modulation. So it is used to overcome the quantization errors due to slope overload and granular noise. So here the step size is made adaptive to variations in the input signal. That type of modulation is adaptive delta modulation. So here first one is the number of beats. So in pulse code modulation it can use 4, 8 or 16 beats per sample. In delta modulation it uses only 1 beat for one sample. Then in adaptive delta modulation it uses only 1 beat for one sample. Means delta modulation, adaptive delta modulation uses same number of beat. In DPCM beats can be more than 1 but are less than DPCM. Means it is moderate in between PCM and delta modulation. Next is the levels and step size. The number of levels depends on number of beats. So level size is fixed. In delta modulation, step size is kept fixed and cannot be varied. Because of that, we face the problems like slope, overload, distortion, and granular noise. But in adaptive delta modulation, as per the signal variation, the step size varies. In DPCM, number of levels is fixed. Then quantization error and distortion. In PCM, quantization error depends on number of levels used. In delta modulation, slope, overload, distortion, and granular noise are present. In adaptive delta modulation, it overcomes the slope, overload, distortion, and granular noise, but quantization noise is present. And in DPCM, slope, overload, distortion, and granular noise both are present. Next point is the transmission bandwidth. Highest bandwidth is required since numbers of bits are high. But in delta modulation, lowest bandwidth is required. As we know, delta modulation is used to overcome the disadvantages of PCM. And then adaptive delta modulation is similar to delta modulation, that is lowest bandwidth is required. And DPCM is in between PCM and delta modulation, means bandwidth is required is less than PCM. Then feedback. In PCM, there is no feedback in transmitter or receiver, but in delta modulation, feedback exists in transmitter. Then in adaptive delta modulation, feedback exists, and in differential pulse code modulation also feedback is exist. Last one is the complexity of implementation. In PCM, system is complex and the other three are simpler than PCM. So this is all about the comparison, and this is all about today's class. Thank you.